And I really don't want to watch myself. Okay. Let's start off with sine and going forward. Let's say you are given an angle, and I'm going to say, let's go with 210 degrees. And you're asked to find the value of the sine function. Realize with the sine function, you have input and output, and I'm just going to write this to emphasize. You know what? I just realized it might be better to write it this way. So we have our input variable. When we deal with trig functions, we put into them angles. The value we get out of the functions, the output for sine, they are just numbers in between -1 and +1. We will only get numbers between -1 and +1 for the sine of any angle. And the sine is equivalent to looking at opposite over hypotenuse. So if you think about opposite over hypotenuse, hypotenuse has to be larger. And so with it having to be larger, you're going to get a number between 0 and 1. Then when we throw it into the mix of being able to turn negative and being able to be a non-triangle. So most of the time when we're looking at angles, we're looking at angles that can create a triangle where you have a hypotenuse that is larger than the two legs. But realize that if you're dealing with 0 degrees, that you don't actually have a triangle. When you're dealing with 0 degrees, that goes beyond being able to work with a triangle because you're just getting this flat line segment. However, if you can imagine, maybe I should draw it on here. If you can imagine an extremely small angle and you are working with a right triangle, you can look at the sine of that angle. And the smaller this positive angle is, you'll notice that the value of sine is close to 0. So we turn this into a continuous function when we blast out of the right triangle and take it to the next level. Also, with a right triangle, you're stuck with angles between 0 and 90. By applying the notion of a standard angle that's allowed to turn and turn and turn and turn, we are able to then talk about a function for sine that goes positive, negative, back and forth. All through the time, you can imagine a triangle within each quadrant. But once you get past the triangle, you can look at the unit circle alone without the triangle and treat that as its own entity. And that's where we're at. Let's treat the unit circle as its own entity now. We want to remember that sine represents y values. Okay. By practice quiz, what do you mean? Practice for tomorrow's quizzes? If you're meaning practice for tomorrow's quizzes, I'm actually going to go through some many examples that'll suffice. Oh, got it. Okay. All right, here we go. If I am trying to find the value of sine knowing that I'm at 210 degrees, I want to know where 210 is. I know that right here I've reached 180, and I know that this much of an extra turn is another 30 degrees. Adding 30 degrees to 180, I get 210 degrees. Be aware that there are two different ways to cut this. And that's actually why I have different colors. This particular circle has different colors for the vertical and horizontal lines. Some of them are red, some of them are green. The reason I have them as different colors is because they represent two different ways to cut up the unit circle where they actually don't have anything to do with each other. They meet up at every quadrangle. These angles are your quadrangles. Don't you love that name? Quadrangles. Those are angles that land on the edge of one of the quadrants. All of the unit circle specified angles. Come on. Yeah. All of these other unit circle specified angles are coming from two different types of cuts. One of them is cutting each quadrant into thirds. And so I've got cutting them up into thirds is based on horizontal and vertical red line dashes. Then the other way that it's cut up is quadrants are cut in half. And those are represented by the green. When you're dealing with the quadrants cut in half, you're always dealing with angles where the sine and the cosine are both either positive or negative root 2 over 2. And that's convenient to kind of be aware of. If you're aware that those particular 4 spots on the unit circle are places where the sine and cosine are either exactly the same number or opposite signs of the same number, that's going to help you with tangent and cotangent. Tangent is sine over cosine. So if I am dealing with one of these two angles, that's where my sine and cosine, my x and y coordinates, are either both positive root 2 over 2 or both negative root 2 over 2. And if they are the same exact thing, then the answer is 1. So the tangent of 45 degrees is 1. The tangent of, 180 plus 45, 225. Then let's add on that cotangent is tangent's reciprocal. With that said, then if you are on a 45-degree angle, be it 45 or 225, what's the reciprocal of 1? The reciprocal of 1 is 1. So that takes care of tangent and cotangent for both of these angles if you bring in that awareness of the fact that the sine and the cosine have the same exact root 2 over 2 values there. It also helps with these two. Those are places where the tangent and cotangent are both what number? So here I am 90 plus 45, 135. And over here, that is 315. What is the sine over cosine? Yes, I'm recording it. What is the sine over cosine ratio if we are on one of these halfway through quadrant points? If I look at this point, the sine value is positive root 2 over 2. The cosine value is negative root 2 over 2. 1/2 equals at 30. In a way, yes. You have to be careful with the 30-60 angles in keeping straight whether you're dealing with 1 over 2 or if you're dealing with root 3 over 2. I'm pointing out the when sine and cosine are root 2 over 2 because if you become aware of those, it makes this process a little bit less consuming. And so when I'm dealing with tangent at one of these two angles, what is the value of tangent? Tangent is sine divided by cosine, negative 1. Both of these are where tangent is equal to negative 1. And what is the reciprocal of negative 1? What is the reciprocal of negative 1? Perhaps I should just go with the previous response. They're all negative 1. So soak that in a bit. Now I'm going to go back over to where I was and actually do one entire problem. So we found 210 degrees. The sine of 210 degrees is exactly the same thing as the y-coordinate of this point. And if you're familiar with the position that 210 is among the unit circle, then you're aware that you have these three negative y values. As you go away from the origin, they are negative 1 over 2, negative root 2 over 2, and negative root 3 over 2, giving us a 1, 2, 3 as you go away from the origin. So 210 is the negative y coordinate. That is the first one we run into on the negative y-axis. So it gets negative 1 over 2. You're going to reach the point where, as you do the unit circle, you just quickly write these answers without necessarily showing much work. And you'll have a unit circle in front of you too. Now, what if I asked you for the cosine of 210 degrees? So that's that answer. I'm going to erase it. Write it down if you wanted to write it down. And now I'm moving on to what is the cosine of 210 degrees. And let me point out to you that cosine also has the issue of its output is between negative 1 and 1. Input are the angles. Output are just numbers between negative 1 and 1 because, again, cosine is adjacent over hypotenuse. Hypotenuse has to be a larger side than the legs. So when you have adjacent over hypotenuse, you're getting something between 0 and 1. And correct, Jason, correct. So as I look at 210 again, but this time I ask what is the cosine, I'm actually asking what is the x-coordinate of this point. And if I look at it in relationship with the other unit circle special angles, I can see as I go away from the origin on the negative x-axis, I hit one of them away, 2 of them away, and 3 of them away. 1, 2, 3. So those very specific spots in quadrant 3, their x-coordinates go 1 over 2, root 2 over 2, root 3 over 2 with negative values. The x-coordinate then is that negative root 3 over 2. I'm going to start talking about the other 4 trig functions, but first I want to double check that you're feeling comfortable with sine and cosine. So I'm going to give you some sine and cosines, and I want you to see how quickly you can figure them out. Oh, was that a hand? Did somebody put a hand up? Because I heard a dink noise. I don't know. Okay. All right. Sine of 150, sine of 330, cosine of 150, and the cosine of 330. Then all right, so I want you to see how quickly you can get these. Do you need me to give you a minute? I'm giving you a minute to see if you can get these answers relatively quickly. Have you had enough time to try on your own? If I don't get a response, then I don't know if you're understanding. I can see that Jason's good. That's only one person, though. Are you guys feeling comfortable with sine and cosine? Okay. Okay. All right. So let's double check. Excellent. Okay, now I'm starting to see the responses sound like you're getting it. 150, you want to know that that's 30 degrees shy of 180. So going backward 30 degrees, I hit this spot. Sine is the y-coordinate. The y-coordinate is positive 1/2. If I look at cosine of 150, that is the x-coordinate, and that x-coordinate is the third one out on the negative x-axis. So it's negative root 3 over 2. But with tangent is sine over cosine. And that is very important. It's not off topic. That's something very important to be aware of. Tangent is sine divided by cosine, which means actually tangent is y divided by x if you're looking at the circle and the points on the circle. For 330 degrees, That is 30 degrees before hitting 360. And if I want to know the sign that I'm looking at, what is the y coordinate? It is the first one down, -1/2. Cosine is the last positive x out from the origin while you're inside the circle. So you're getting √3/2. Did somebody say something? Okay. 135. 135 is 90 plus another 45. And anytime you're halfway through a quadrant, the answers to sine and cosine are both either positive or negative, √2/2 every single time. But let's look at it. For sine, the y coordinate is positive, and it's the middle of the three. I can't draw straight across, apparently. It's the middle, which is the second one, and it's on the positive y-axis. For the cosine, it's also the middle one, but it's on the negative x-axis. Then you also want to be comfortable with things like, what is the sine of 90 degrees, 180 degrees, 0 degrees, 270. You want to know your quadrangles. And keep in mind, sine is the y coordinate. So if I'm right here at 90 degrees, the y coordinate is what number? What is the sine of 90? Somebody answer so that I know I'm not alone. What is the sine of 90 degrees? Thank you. If you land on 180, what is the y coordinate of this point? 0. Thank you. So that's the sine of 180. 0 degrees, what is the y coordinate of 0 degrees, which is the same as 360? What is the sine of 0 degrees? So what is the what? Yeah. And then if you land on 270, what is the y coordinate at that point? -1. And from there, do you feel like you can find the cosine of all four of those? So real quick, what is the cosine of 0 degrees? What is the cosine of 90 degrees? 180, 270. Okay. Okay. When you're focused on x coordinates, when you're at 0 degrees, that x coordinate is 1. When you're at 180, the x coordinate is -1. But when you're at the top and the bottom of the circle, the x coordinates are 0. Now, when I move into tangent and cotangent, I want to be aware of sine and cosine. Tangent is always sine over cosine. So if I ask you, what is the tangent of, let's go with 330 degrees. Then you're looking at the sine of 330 degrees divided by the cosine of 330 degrees. And we found that already. If I look at the fraction negative 1/2 divided by root 3 over 2, the over 2's cancel each other out, and I get negative 1 over root 3, which I'm perfectly happy if you leave root 3 in the denominator. But let me also point out to you, because I find it very helpful, but you may not, so it's up to you, that if I look at a line that goes through the origin and goes through the point on the unit circle that lands right there at 330, the tangent of that angle is the exact same thing as the slope, because you are looking at what is y divided by x when you deal with slope. And a second point is 0, 0. So your slope is always going to wind up being the same thing as the tangent of the angle. That means if you land in quadrants 2 or 4, your tangent is negative. Those are all quadrants where it has negative slope. If you land in quadrant 1 or quadrant 3, you're getting positive tangents. Cotangent is just tangents reciprocal. I personally prefer to do my best to avoid cotangent. I will try to reciprocate it and deal with it in terms of tangent. Good question. Very good question. So tangent of 150 degrees, that is directly across the unit circle. The answer is yes. And this is where I like to look at this circle when I'm dealing with tangent or cotangent. Always, 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 tangent and cotangent have their identical values directly 180 across the unit circle. We just saw that at 330 degrees, the tangent value is negative 1 over root 3. And that is the same if I think about the sine over cosine with 150. Now, I want to take a look at this pair. This angle is 90 plus 30, 120. This angle is 270 plus 30, so 300. All right. At 120 degrees, the sine is root 3 over 2. The cosine is negative 1 over 2. The over 2's cancel, and I wind up getting negative the square root of 3. If I look at 300 and I do the tangent of 300, then again I'm looking at sine over cosine. Sine is the y-coordinate. This y-coordinate is the third one away from the center on the negative side of the y-axis. The cosine is 1/2, positive 1/2. If you compare this ratio with, oh dear, I think I lost. Okay, there it is. If you compare those two ratios, I want you to notice that sine is √3/2 plus or minus. Cosine is 1/2 plus or minus. Depending on which quadrant you're in, they swap who's negative and who's positive. But that keeps tangent the same. Now, I personally find it really, really helpful if I realize that there are certain slopes going on. When I'm at a 45-degree angle, I am at a slope of 1. The tangent of 45 degrees is 1. If I look at 60 degrees, that line is steeper. Will a steeper line have a larger slope or a smaller slope? Will a steeper line have a larger slope or a smaller slope? Right. Now, √3 versus 1/√3. √3 is a number larger than 1. The steeper slopes have √3 for their tangent. This is √3 for tangent. This is √3 for tangent. And then steeper slope but negative, your answers to tangent are negative √3. Then if I look here, do you see that this is less steep than when I was at a slope of 1? So if I'm comparing that rainbow slope with the line that had a positive 1 slope, do you see less steep means smaller? And with smaller, that's where I'm going to get 1 divided by √3 instead of times √3. That means it's helpful for you to realize that steeper means the tangent is plus or minus √3. Less steep means the tangent is either 1 divided by √3 or negative 1 divided by √3. And if you look at whether that's a positive or a negative slope, you can determine the positive or negative on that. The only slopes you're dealing with within quadrants are 1/√3, 1, and √3. The only other slopes that get involved are a slope of 0 and a slope that is undefined. That means if I ask you what is the tangent of 90 degrees, meh. If we're looking at what is the tangent of 90 degrees, when you sit there, the line that goes through the origin has an undefined slope. Tangent is undefined at 90 degrees. If I look at it as sine over cosine, that's a place where cosine is 0. Dividing by 0 means bad things. At 270, tangent is also undefined. At 0 and 180, tangent is equal to 0. Then when you bring cotangent into the mix, you have to remember it's reciprocal. That means with cotangent, Where tangent has a 0 slope, cotangent is is there any other schoolwork besides the practice test for today? I'm too lazy to check the calendar. Oh my goodness. That's it. Yeah. What is cotangent of 0 degrees? And what is the cotangent of 180 degrees? Can someone tell me? Based on what I've been saying, are you getting the idea? What is cotangent at those angles? No, the practice test is due tomorrow. You have 2 days to work on it. Sorry, Jason. If you're bored, I can point you to places to go play with math. No, the test is not Friday. I pushed the test to Monday because we need some time to absorb this and make sure that it's all clear. Yeah, I feel you on that one. So my question to everyone was, do you know what the cotangent of 0 degrees and 180 degrees is, knowing that the tangent of those angles is 0? What is the reciprocal of 0? In other words, 1 over. Yes, undefined. These, where you have a slope of 0, cotangent is undefined. Tangent is 0. Where you have an undefined slope, that's where tangent is undefined, but that's where cotangent is actually 0, because cotangent is actually the x coordinate divided by the y coordinate, because cotangent is cosine over sine. So if I'm looking at this angle right here, which is 90 plus 30, 120. If I'm looking at 120 and someone asked me what is the cotangent of 120, I would first think, what's the tangent of 120? And I would look at the fact that this has a negative slope and that it's steeper than the -1 slope. That makes tangent the √3, but that makes cotangent the reciprocal. So the cotangent of 120 degrees is equal to -1 over √3. And you can always look at what is the cosine divided by the sine, which would be the x-coordinate divided by the y-coordinate. So with tangent and cotangent are the harder ones. If I ask you, what is the secant of 180? You actually want to look at what is the reciprocal of the cosine at 180. So if I'm over here at 180, cosine is the x-coordinate. What is the x-coordinate at 180? The x-coordinate. It's really easy to mix up the x and y, unfortunately. And Alec, if you have an issue with mixing the zeros and the ones up, I can help you with that, because I have that issue too. And I had to learn how to compensate. So -1 is the x-coordinate of this point. And the reciprocal of -1 is -1. So that's the secant of 180. Good. Now I'm going to erase a little bit. And keep going a little bit more with this, because if this makes a lot of sense, when I go over the backward, it's going to go quick. If I ask you what is the, come on, wakey up. There we go. If I ask you what is the cosecant of, let's go with 150. No, I'm tired of 150. 300. 300 degrees is 270 plus another 30. And who is cosecant's reciprocal? Again, who is cosecant's reciprocal? Thank you. Yes, sine. So that means I need to find the sine of 300 degrees and take the reciprocal. Sine is that x or y coordinate. It is the y coordinate. And based on its relative position, it is the third one away from the origin on the negative y-axis. So the sine is negative root 3 over 2. How do you reciprocate a fraction quickly? Flip it. So that negative root 3 over 2 flipped is negative 2 over root 3. And I am perfectly okay with you leaving roots in your denominator. I'm hoping that at this point, many of you are feeling confident with finding, for particular angles, these functions. Now, going backward is when we have to find the angles given the answer to the trig function. I want to point out to you that if I can find your practice test, that's not your practice test. I put that in the wrong spot. Where did I put the practice test? I don't know. But let me find it. Let's see. And this is going to take too much time, unfortunately, but you're still with me for another 3 minutes. Okay, practice test. What I covered today was trying to help you understand how to do problems like 1 through 6. But once that makes really strong, solid sense, this is going to be a lot easier. So this is really more about solving equations, trying to find what the input angle is based on the answer to that trig function. So I'm going to go back over to a unit circle. And let's say I asked you, what is the angle for which the sine is equal to negative root 2 over 2? If you realize that sine is the y-coordinate, then you're looking at where is y equal to root 2 over 2. And if you look at the three levels, root 2 over 2 is the middle one, and it's negative. That would be if it were positive. Yeah. So if sine is equal to negative root 2 over 2, which angles? (180 plus 45) and 360 minus 45. So on a round one around the unit circle, the answer to theta are those two angles. But if I want to know all solutions, then I have to look at taking each of these and looking at all of their, what was the word for lands on the same thing? So like 30 degrees is to 360 plus 30. Coterminal. Thank you. Coterminal. All the angles that are coterminal with these two are also solutions to this trig equation. And those coterminal angles are found by adding or subtracting 360 any number of times. You don't have to write plus or minus because it's understood that n can be positive or negative. Well, my time is up, and today you need to turn in homework. Yeah, that one. Today due is homework 6-7 corrections. The practice test, you have 2 days to work on it. 2 days. And I'm not going to give you the answers until you have had time to work on it. If you want to know if you have correct answers, I will tell you whether your answers are correct or not. Okay. Then if you have any questions or need to talk to me, stick around. Otherwise, I will see you tomorrow. Bye-bye. Mm-hmm. Yes, I know that you need a lot of people need it, not just you. Okay. And let's see. Chris, Dylan, Madeline, Michelle.
Yep, all good. Thank you.
Okay. And then Michelle, Dylan. Are either of you having problems with your internet? I have had some people say that it freezes on them and they can't get off. But I also want to make sure that you were in class paying attention. So, Dylan and Michelle, if you are there, say something in chat or out loud. Or you can just leave the meeting as well. But I want to make sure that you are on the other side of the computer. Michelle, Dylan. Okay. Getting no response, I'm going to take you off of the meet. I hope that the issue is just that you're having computer troubles. Okay. Okay, good. There we go. Dylan. Dylan, are you there? Dylan, are you there? Okay, I'm going to remove you from the class, and class is over. Hopefully you were paying attention, and I'll see you tomorrow.